Hello everyone. This is in continuation of design of retaining wall. So we have done with in the previous lecture the dimensions of T-beam. So let us find out the factor of safety against overturning and sliding. So what will happen for the overturning moment is 118.07. This is kilonewton meter. This is P value, that is P into H by 3. This is P H by 3. And what is this? Stabilizing moment equals to 261.81 kilonewton meter, which we have calculated. This is because of the total vertical loads which is giving moment about A. So factor of safety is 261.81 divided by 118.07. This is coming 2.22. So this is greater than 1.55, which is required. So this is okay. Now you can calculate the factor of safety against sliding. Sliding force equal to active pressure. Active pressure is P, that is 70.83 kN. And what is the resistance sliding? Mu W plus half Kp gamma H square. H square because on the back side of the wall, which is slant, there is this type of thing is there. If your T-beam is in this way, this is your T-beam in this way. We have got this value 600 ground and 400 this is 400. Now this is your, so this value is your H equal to 1 meter. For 1 meter we have to calculate 1 by 2 Kp gamma H square, which is giving you the force, you can say balancing force. So we are added this thing. This is coming 117.28 kilonewton and factor of safety 117.28 divided by 17.83, which is coming 1.66, which is greater than 1.55. This is okay. So you can check the stability requirements with the help of this thing. So there should not be any doubt. I think it is clear. So we'll go for the design, structural design, that is the steel, quantity of steel, how do you find out. So let us see what is this the design step. Pressure at base, that is 5.67 into Y. Here Y is a 4.6, so we are taken 26.08 kilonewton per meter square. So moment equals to, if you consider 1 meter length, 1 by 2, 26.08, and height 4.6 into 4.6 by 3. This is your moment, Ph by 3 you can say. So this is coming 91.98 kilonewton meter. And what is shear? Shear is 1 by 2, 26.08 into 4.6 divided by 2. This is 59.8. So we have got the moment and shear. So what we'll do, for the moment you have M equals to AST sigma ST into JD. Here J you can say take 0.9 or 0.87. So you can always find out the AST equals to M by sigma ST into JD. So this will be your 91.98 to 10 to the power 6 Newton meter divided by 230 you can take into sigma ST J 0.9 into D. What is D? What is D? We have find out the D. D we have taken the D 400. D is taken 400. So this D is taken 400. So let us find out the value of this thing. This is coming 91.98 divided by 230 divided by 0.9 divided by 400. This is coming 0.3. This is coming 1111 meter milli. This is mm square per meter for 1 meter of length. So you can calculate the spacing. Take 20 mm 5. So you can calculate this you can calculate the spacing. So let us calculate the spacing. If you take 25 mm 5, so this will be AS into 1000 divided by AST. So let us 20 mm, so pi by 4, 20 square into 1000 divided by 1111. How much giving? This is coming how much? Area of 1 bar divided into 1000 divided by this thing. So this is 0.785 pi by 4. This is pi by 4, 0.785. 705 into 400 into 1823 divided by 1234. This is 282. This is 282.77. So let us provide at a spacing at a rate of 280 mm center to center. So you can provide like this. Now for the curtailment, you have to find out the depth where we can calculate this curtailment rule. So we provide like this. So we can curtail somewhere else where we curtail this thing. So this is taken as at a top से y1 ले रहे हैं, तो यहाँ पर required depth क्या हो जाएगी? Required depth will be your that will be this value is 200, this is 200. So if you take cover 50 mm and plus this d1 equals to 250 upon 4.60 into y1. So this will be your d at a d1 you can say at y1 distance where you curtailed. Then moment, what will be the moment? Moment is 1 by 6 gamma h cube this will be 1 by 6 gamma h cube, this will be 1 by 6 gamma h cube. You can calculate this value. This will be gamma h cube into y1, gamma h cube into y1, k gamma y1 cube, k gamma y1 cube, sorry, k will be there. So this will be k gamma y1 cube. This will be your moment at y1. So you can calculate this thing. So this will be 1 by 6 into 1 by 3rd into 17 and to multiply by y1 cube. This will be. So if you find out this moment would be you can say if you find out the AST, or you can say this moment is approximately m by 2, m1 moment. So m by 2, you put it to m by 2, and with the help of this you have to calculate the y1. So y1 can be calculated in this way, or we can approach something like this. How we are getting? This is AST. So this can be calculated by putting this equal to m by 2. We'll get some value of y1. We can calculate the value of y1. So y1 will gives you some value. Maybe you can calculate m by 2. M by 2 is 91.8 kilonewton. The moment is half. So you can calculate this. This is your 1 by 6, 1 by 18 into 17 into y1 cube equals to that is 91.98 divided by 2. So we can calculate the y1. Y1 equals to, let us check, 91.98 multiplied by 18 divided by 17. This is 97.39. 18, 17 and 19.73. This minus. So this is your 7, 3, give your 91 point something, 1.98 divided by 2 into 18 divided by 17. This is coming 48 point something and 69. So 3.46 into 3.46 into 46 gives out 41.2. So this is coming y1 cube is this. Y1 equals to something 48.69. 48.69 root we can have the shift 48.69 shift 1 3 gives out no error आ गया. y1 is equal to 1 by third 48.1 by third 1 by third x cube है 1 by third. So this is coming approximately 3.8 into 3.8 into 3.8. This is coming 53.67 into 3.67 not 49. So 3.6 you can say, or you can have 3.5 meter. So at 3.5 meter approximately we can calculate. So we have to curtail the bars, the 50% can be curtailed. Now you can go for the shear design. You can go for the shear design also. So this is how the stem is designed. So 20 mm at spacing and 50% is curtailed at a distance of 3.5 meter approximately. Y1 is equal to 3.5 meter. So your reinforcement detailing will be something like this. In this way, this is you're putting on this face main bar, this is your, and this is distribution. So this is 20 mm 5 at a rate of 280 mm perhaps center to center. So curtailment will be somewhere here at a distance of, you can have 3.5 meter. 50% will be curtailed. 50%. This is 50%. This is 100%. So you can do. We will discuss this later on for the design of shear force, which will come over here, and we'll check for this year. So we'll continue in the next class. Thank you for being with me.